Mabuhay! Welcome to Tambayang Radio. I am your host for today, Akila A. Alonzo. For today's topic, we will tackle on the 18 functional group and its application in life, starting with the triplets, alkane, alkene, and alkyne. Remember that functional groups are groups with a specific group of atoms that share the same function. With this tree, the similar feature is that all of them are composed of hydrocarbons. The only thing that sets them apart is their type of bond, wherein alkane has only single bonds, alkene has double bonds, and guess what? Alkynes has, triple bonds. Alkanes are often found in things in the chemistry industry, specifically for things like gasoline and lubricating oils, going as far as helping in electricity generators, cooking, pesticides, and many more. In fact, we can easily find it in our house since even a Vaseline is an item under the alkane group. Alkene, on the other hand, feel like for me serves an even bigger purpose because it is usually found in plastic, detergent, lacquers, and even used as fuels, which today is a very hot topic, by the way, with inflammation of gas in the Philippines especially. Well, continuing on, we have alkynes. Alkynes are usually applied in medicine, wherein it plays an important role in making anti-tumor agents. In the industry, it serves a vital role as it creates organic compounds like chlorophene, vinyl, chloride, and even polymers. Anyways, enough about the triplets. Let's move on to arene. Arenes are notably identified for the benzene ring, thus making it easier to use as plastics, synthetic fibers, rubber lubricant, dyes, resins, detergent, drugs, and more. Moving on, we have halides. And just like the term suggests, halides are made of halogens, specifically the 7A group in the periodic table. F for fluorine, Cl, chlorine, Br, bromine, and I as in iodine. Halides are often used as refrigerants, propellant for aerosols, foam plastic, and are very good solvents because of their strong bonds. Next in line is the extroverted clean freak party animal, alcohol. Now I know you've heard about this before, and obviously, we can already guess that this functional group is mainly used for the production of alcohol beverages and disinfectants, which by the way was a trending hit during the start of COVID-19. But besides all this, alcohols are also used as fuel, antifreeze, preservatives, and even solvents. This is identified with the hydroxyl group at the end of its structure. Now, the next functional group we're to discuss is identified by the middle oxygen in its structure, and that is ether. Ethers are widely used in the field of medicine, serving as antiseptics. However, in our homes, ethers are usually found in the kitchen, bedrooms, or even in our cabinets. They are found in oils, solvents, perfumes, dyes, waxes, and even gums. Fun fact, in 2003, a study was released for the addiction of ether consumption. Consumers became dose dependent as they started eating it. But of course, this is inadvisable because it can cause irritation and even as deadly as death itself. So slow down with the gum. Anyways, let's move away from the topic of death and move on to sulfides, which is clearly identified by the fact that sulfur is found in the middle of the structure. These are commonly found in manufacturing industry, especially sodium sulfides, which are used to make papers, water treatments, textiles, and even rubber chemicals. Now, to tie all this stuff, of course, we'll need to discuss tiles. Get it? Instead of rap, I use tie to create the word tile. Okay. I admit it was kind of corny, but speaking of corny, tiles can be found in what we consume, since tile is a sulfur compound that is found in food like garlic, onion, cabbage, and even our daily dose of Nescafe 3-in-1. Boom na boom! Go gising coffee! To clarify, we are not sponsored pero open for sponsor. Just okay. Going back to the topic, tiles can also be found in beverages like beer and is identified by the SH group at the end of the structure. Next on the list are amines. Amines are identified with nitrogen in its structure, regardless if it is found at the middle or at the end bonded with hydrogen. These are commonly used in the medicinal field to create drugs. But aside from that, they are also used for developing chemicals for crop protection, medication and water purification, and also in household products like polish, dyes, rubber, resins, and even used in the textile industry. I guess you can say that it was a big boom. Get it? Mines? Boom? Anyways, let's talk about nitro. Nitriles for me are a bit special, since this is identified by the triple bond connecting to a carbon and a nitrogen as its terminal. Speaking of terminal, nitriles are also used to create antibiotic drugs to treat breast cancers. Besides this, they are also used to create nitrile gloves, seal, and hose. Okay, moving on, we'll now discuss the functional group which have C double bonds, starting with aldehyde. Aldehydes are particularly noted for the terminal oxygen. This can be used for tanning, preserving, side chemicals like insecticide, germicide, fungicide, and even preservatives. And if you may not have noticed, we still have more. Going on to ketones. Ketones have double bonded O within the structure. These are great solvents and are mainly used as such. It is found in acetones, paint removers, paint thinners, medicine, textile, varnishes, and even plastic also. Continuing on, we have carboxylic acids, which are identified with the hydroxyl group as its terminal. These are used in the production of polymers, biopolymers, coatings, adhesives, and pharmaceutical drugs. Of course, in our homes, carboxylic acids can be used as solvents, food additives, antimicrobials, and flavoring. For the next functional group, we have esters. Now, surely I know what you're thinking. It rings a bell, doesn't it? Similar to, I don't know, ethers? Well, that's because both are really similar in terms of structure. Just like ethers, esters are also identified with oxygen within the structure. However, just like what I've told you, esters are included in the functional group which has a double bond. However, their application are still somewhat different. Esters are used in synthetic flavors, perfumes, cosmetics, and are also used as solvents like coatings, paints, and varnishes. Another thing that might ring a bell is amine. Similar to amine, both also has the same structure, and the only difference is that amides have double bonds. While in terms of application, amides are mainly used for structural purposes because it produces resilient structural materials like nylon. Amides can also be used in medicines. For the last two functional groups, we have the double twin bond, carboxylic acid halide and carboxylic acid anhydride. Carboxylic acid halide, which just like a halide, is composed of terminal halogens, fluorine, chlorine, bromine, and iodine. Only difference is that it has a double bonded O, whereas carboxylic acid anhydride are a bit more special, with two double bonded O with an oxygen at the middle. The acid halides are mainly used for organic synthesis, whereas anhydrides are used for pharmaceuticals, industrial chemicals, explosive, and perfumes. Now, I know that there are many more applications to this, but of course, I could only list down so much. If you wish to learn more, check out my page and hit subscribe. And that's it for our segment today. See you next time on Tambayang Radio.